Today I am going to explain you a basic of Kirchhoff's second law. Here you can see that from the diagram, one side is negative of this battery, one side is negative, another side is positive. So what is the direction of the current? Direction of the current will move from here, okay? And here again it is same. We have another battery. We will give the name E2, and it is also in the direction of what? Here the direction is negative and this is positive. The current will flow from the positive, and you can see that from there the current will move, and here again it will move, and it will move like this, and then and it will move from there also. Okay, so now we have this diagram, and you know that this KVL means Kirchhoff's voltage law. We apply for where? We apply for a closed loop. So you can see that these are closed loop. So first I have to drive the equation. Okay, first I have to drive the equation where we have to drive the sum of the algebraic sum of IR is equal to what? Sum of E. That we have to find out. So now how we are going to do it, this one? First you will understand the law. In this you can see that how many resistance we have. We have 1, R1, R2 and R3. Three resistance we have. Okay. And the current is flowing from R1. You can see that the current is flowing from R1, and it is in the direction of, it is in, current is in the direction of resistance, so we will write it is positive. Okay, so I1 R1, I have written what? It is positive, so there is no use to write the positive. This side is IR, that is why I have written IR over here. Okay, now again you can see that here I1. Now again the current will move over here, and it follow this loop. Okay, so now when it will come this side, the current direction is this side, now moving over here, and you can see that now its direction is what? Its direction is the current. You can see that the current is, it is in in this direction, moving like this, and when it is coming in this path, the direction is opposite. Direction is opposite. You can see it is follow like this, and here it is follow like this current. You can see that the arrow mark. Now it is what? It is opposite, because the current is coming from this side, but from this side the current is opposite. So what happened? Because when it is in the direction of the current, then we can able to write is plus, but when it is opposite to the direction, then we are going to write I2 R2. Okay, and what about this one? EMF, because E is written. So you always keep in the mind, when it is moving from negative to positive direction, it is, we writing plus, but you can see that negative to positive it is plus, but positive to negative it is minus. Okay, so this is my equation 1. Now what about equation 2? Now you follow this equation also, this side also. So when you follow this one, this side, you can see that here again for this side, so this side is my I2 and I2 R2 is in the same direction, so we can able to write I2 R2. And here I2 R2 again it is moving in this direction, and when it is moving in that direction, so the direction is same. Direction is same. So you know then when the direction is same, at that time you can able to write plus. So we can able to write I1 plus I2 into R3 is equal to, here you can see that the EMF. So EMF for this case, we have only one EMF is present. Okay, and it is moving from negative to positive. So again you know that negative to positive it is plus only. So we will write E2. This is your second equation. And like that, in your numerical questions, the values are given to you, and then you are going to find out the equation, two equations, and then you solve it. In the next class I am going to explain you this.